Hey guys, Mr. Bowman here. Today's learning objective is in pink, and we are learning to model a skate park on DESMOS. Before we get on to DESMOS, I just thought I'd describe the type of skate park that I'm looking for. So let's say, I don't know, this area here is grass, and then our concreted skate park starts here. We're probably going to want a bit of a flat bit of concrete to start off with, and then maybe that would move into a bowl. And then that would have room for them to carry on the other side. I'm thinking on the other side, we're probably wanting a bit of a rail, so maybe a diagonal bit of metal bar with a straight line going across, and then that going down. And then after that, maybe we're wanting more of a flat descent leading into another flat area with a kind of a bigger ramp for the more extreme skateboarders. And then on there, you'd have a little top for them to stand on, maybe a little bar up there for safety. And then that would go down to the ground. And then another little bit of concrete there. Maybe people can play squash or something against the wall, and then some more grass on the other side. So just our little skate park. So the thing I'd want to note is our y-axis, our x-axis would probably be the ground level. We'd probably be looking to use that as our y-axis, and that means our x-axis would go along there. So hopefully it would look a bit like that as well. So what I'm going to do is I'm going to flip over to DESMOS. Hopefully I'll have the shape available to us so we can see it. And we're going to start modeling this. And the key thing we want to note is we want to start thinking about the features of our graphs and the features of our skate park and how we can represent this scenario using graphs. Okay, guys, we're back. I've managed to split my screen. I've got on the left-hand side our skate park with our axes. And on the right-hand side, we've got our DESMOS account. First thing I want to note is the scale's a bit weird. It's going up in tens. So what I'm going to do is I'm just going to change the step. So the step, that means I can see every one of that. Why didn't that change it? That's all right. We'll get through it as well. Okay, so I've messed around with my axes. We've got the height of our ramps up here, and we've got the length or the ground level of our ramps here. So the first step is let's try and start modeling this. So the first starting point, we've got a flat line along the ground, and that there, we'll probably have to make an assumption how long that is. Maybe they would want 5 meters of space to get a bit of speed up. So we need to firstly put the line in. So that line needs to be on our x-axis. And that line would actually be y equals 0. So you can see that black line popped up. And we only want that between 0. So if you're thinking of the domain regarding the x value, we're only wanting that between 0 and 5. There you go. And we can see that. We can see the starting point of our skate park there, just that start point. And then we've got a bit of a bowl that's coming down. And that bowl, it could be a parabola, but to me it looks more like a hyperbole. It goes down, but it never quite touches the ground. It kind of has that leveling off effect like an asymptote. So I'm thinking that is going to be a hyperbole. So let's think of a formula that will help us with that. Okay, so let's start in hyperbole. Let's just do 2 divided by x, see what that looks like. So randomly pick 2, but we can kind of see with the mouse that portion between y1 and x5, that looks pretty good. That kind of looks like what you'd expect of a skate park, how it's going down. So that point there, what we need to do is we now need to move that down 1, so it's in line with the x-axis. So let's move that down 1, and we can see that's been moved down. We now need to move that across, so we probably need to move that across by 3 units, 1, 2, 3, to get that to 5. So let's go -3. And from there, we need to think, what about our domain? Where do we want this to stop? And I'm thinking we probably want to stop it at 10 there. And then it would level off after 10. So we're looking at a x value range between 5 and 10. So we're going to put that in. I'm going to copy and paste that domain thing and change it around. So we want to start at 5 and we want to finish at 10. There we are. So I'm pretty happy with that. So that looks like that. So it maybe could be a bit deeper. We can see the bowl is less than a meter, but given it's a public park, we don't want it to be too dangerous. So maybe that makes sense for it not to be that steep. Okay, so the next part of our graph, we wanted a nice big flat range. So again, let's call that 5 meters as well. So at that point there, so we need to find the value of that. So the x value is negative 7.71. So that's going to be our straight line. So we need to go y equals negative 0.71. There we are. So we've now got the ground of that bowl. And as we said before, we want it to be 5 meters. So we're going to limit that between 10 and 15. Oh, so 10 and 15. There we are. We can see we've got the ground of our shape. We then want to start thinking about the next part of the bowl. How are we going to get that back up? So we probably want to connect it from 15 to 20. Again, I'm liking the shape of this hyperbole. So it starts shallow and then it goes a bit steeper. So let's try to use another hyperbole, maybe with an asymptote scooting along the bottom there to help us with that. Okay, so our first hyperbole had an a value of 2, so we probably want to stick with 2. The issue is this part here, that's going in the wrong direction, but we can switch it around and make it a negative hyperbole to help us with that. And we can see this area down here, that's where we're looking for our bowl. And again, what we did is we did -1 in the first graph, so that lowered it to the level. And now we need to get that that x-intercept all the way up to 20. So we've got to think that's -2, and then we've got to add another 20. So we've got to shift that over 22 units. So we're going to go -22. And perfect, so that's got us to our x-intercept where we're looking for it. And like we did before, we don't really care about the rest of the graph. We only care about it between the domain of 15 and 20. So we're going to copy and paste our domain formula. We're going to go 15 all the way up to 20. And there we go. That looks like that's finished our bowl. So we now need to start thinking about the landing and the rest of our work. Okay, so we've done the beginning bit. We're down to the bowl. Let's move our graph over. So we're looking to do a big flat landing with a rail on top as well. So let's say between ramps, maybe we want that to be 10 meters. So what we can do is we can use our formula from above. We're looking to represent our ground, and we want that between 20 and 30. There we go. So we've done that ground. So that would be our concrete ground. And on top of that, we need to put in our kind of our rail, so to speak. And just thinking, what's a safe height for a rail? For me, that's probably, it's a public safe park, so we wouldn't want it too much. So maybe 0.5 meters or half a meter, so something like knee height, enough to kind of ollie up to it. So let's do negative y equals 0.5. So we've got that line, okay? So we've got that there. Maybe that looks a bit too big. Maybe let's make that a bit smaller. 0.4, probably too big again, 0.3. Maybe 0.3 looks a bit better. And we probably want to limit that to maybe a 4-meter area within our flat landing. So maybe let's say between 23 and 27 for the x values of that domain. So 23 and 27. Perfect. So we can see that. We now need to, obviously that bar is not going to float in the air. We now need to connect that to the ground. You can choose heaps of different ways to connect that. We could go straight down and use the the x23 formula for both of those. We've got a diagonal one up here, so let's try to do a diagonal graph to help us out to get that really close to what our picture or our design was. Okay, so just change my mind, just to save time, I am going to limit that to the y value. So that's going to be, it's going to have a range of between 0 and 0.4. Oh, no, we changed it to 0.3 in the end, didn't we? There we go. And we now need to replicate that on the other side. So that was 27. So that looks like our rail. So if we zoom out, we're looking pretty good. We are nearly done. We've now got a kind of a sloped angle down. So I just want to do that. So I normally start off with y equals x. So that looks like that. We now just need to change that. That's probably too steep. So let's make that 0.25x. There we go. That looks a bit better. Oh, even that's too steep probably. Let's go 0.1. Nope. 0.1x. There we go. So that looks like the right steepness. We need to go downhill. So we need to make it negative. And then we need to move that across. And we can move that across by doing that again. So we move that across too much, but let's move that across to the 30 mark. There we are. And that's moved it all the way to that. And we now need to get the domain right. So let's say we want to limit that. So I've got too many graphs here. Let's say we want to limit that to between 30 and 35. So we got 30 and we got 35. And of course, we're limiting our domain for this range. So that needs to be an X as well. So we can see that downhill working quite well. Okay, so we now need to think of that flat landing. So again, let's try to think of that as 5 meters. And that seems to be finishing at 0.5 there. So we need a flat landing. So y equals negative 0.5. Perfect. And we want to limit that to between 35, so our domain, 35 and 40. Perfect. So that looks good. So we've got a flat bit. And we've then got a curved extreme bowl. And that more looks like a parabola now. You can kind of see that point there would be the vertex. It doesn't look like to be an asymptote. It doesn't look like it's leveling off like the bowls did. So let's try parabola. So x to the power of 2. And we can see that pop up. Well, that looks too steep. Let's try 0.1. Oh, that's probably, or maybe that's too steep again for a bowl. Probably not safe. Let's try 0.5. There you go. That looks a bit better. And we now need to move the vertex to this point here, negative 1.5. So what we do is to do that is we're going to reduce it by negative 0.5, and that would have lowered it. And we now need to move it across to 40, and we're going to go minus 40 in brackets here. There we go, and we've moved that across. So we've used our vertex features to do that. And after that, we need to get the domain right. So let's paste in our domain features, and that's got between 35 and 40, so that's wrong. We actually want between 40 and, oh, how long? Maybe 45. There you go. So that looks like a good ramp. And then the next bit, we're looking for our flat thing at the top. So that looks like it's at about 0.75. So y equals 0.75. Perfect. And we're going to limit the domain. We probably want that only be maybe 2 meters, so 45 to 47. There we go. And we now want our line down to the ground to represent our construction. So that would be x equals 47. And we need that between 0, and we're looking at the range now because we're looking at the y-axis, 0 and 0.75. So we've got that there. And the last bit to add is the ground, and let's finish that up to the 50 meter mark. So that's x equals 0. And that is between 47 and 50. So hopefully that pops in. Oh, sorry, that should be y equals 0, shouldn't it? There you go. And so what I'm doing is I'm just going to zoom in. Based on that, if we zoom in and like that, we've modeled our skate park. If we had the axes a bit better like that, we'll be able to see it a lot more clearer. So hopefully you found this video useful. Let's get into another modeling question.